Okay, let's start with the part 2, and let's see. We want all the different states. We should have all the different signals we need to make all the different states, and I think I'll make it as a function. Nuclear state equals check state, just to make it neat and tidy. And I'll just make a function which returns the state with the string. Let's see. Okay, let's make a function into the function area. Function check state. Okay, and let's make a local function called states equals unknown. I do this because if what I'm doing, unknown. Yeah, that's right. If all the code I have does not manage to give it a state, it will actually return unknown states, and I will know that okay, I did not cover this and this and this state. So return the states you are in. Great. Now we need to know what is what. I don't know where I should start. I think what you do want is in the bottom code you want the code which will overwrite all the other checks. That might be the easiest. Like if I want to know if it's meltdown, this is actually a bad way to program. If ESD then state equals meltdown. Let's see, that's 8 characters. 9, 10. And you'll see later why I do this with 10 characters. It will make the 4th episode a lot easier and save me some code. Okay, so if there's emergency shutdown, please melt down. Okay, that's nice and all that, but what if the emergency shutdown have stopped the reactor? Is it still meltdown? No. It is a meltdown if it's emergency stop and not stop applied. Because if it's not trying to stop and the emergency shutdown have gone off, you do have a meltdown. But else if you have emergency shutdown and stop is applied, then you're in a state of stopping. I'm just taking this in the order which I find easiest to program stopped. And then we need 10 characters. You will see why I do this later. Okay, so now we have maybe I could just use a lot of else if sentences. And that way he will only have one of the states. I was planning to have many if sentences, but maybe else if is just as well. Okay, so now we have meltdown and stopping. And we also need to know when it have stopped. I want to make it notice, hey dude, this thing is have stopped. How do you do that without ruining the current code? This is just going to be more and more complicated. Because if stop is applied and you have emergency shutdown and temp level is greater or equals to 1, then you have stopping. Oh Jesus, this will be complicated. I hate this already. And if you have emergency shutdown and stop applied and temp level equals to 0, which is I've stopped, is state equals stopped, and again 10 characters. Woof. Okay, I mean, I have 3 states and it's already getting overly complicated in my opinion, and I have just picked the easiest ones, I think. But we also have a starting state, and the starting state is if let's make this an else if and make an if in front. Okay, so what we want now, state equals to starting and 10 characters. Because if not, if you do not have emergency shutdown or cooling, not what was last, power off, and temp, this will be a pain to test. If temp level is equal to 0, then it's starting. Okay, so if it does not have any stop signal applied, yes, if it does not have any stop signals applied from either of these things, and if it is below this temperature, it will just say it's starting up. That's great. That's great. Okay, that's great. Yes. Let's take the next state. Else, maybe we should just write all the states we want. And I'll just do this to remember that input code. We want state equals to running. Then we want else if then state equals to cooling and 10 characters, else if then the requirements, then state equals to, what's the next, is alarm. We need an alarm state, and else if let's see, next state equals to depleted. Why is this one shorter? Because I miss a space. That's also a nice thing. If you jump into a loop or something, make sure you just jump in 1 space or so. It makes the code a lot easier to read, because I always know when do I have to apply an end or not. Okay, let's see. Was there any more states? Yeah, power off. I want a power off state. If the MFs are full and you have a power off, then state. This is a lot more than I had in my original video, but it's kind of cool. Power off. Yes, 10 characters was enough, I think. I think that's all the states I want. Yes. Okay, let's get to the code. Assume it's 1, 2, 3, 4, 5 if sentences. Okay, so we have starting. If stop is not applied, well, if no emergency shutdown, no cooling, no power off, and temperature level equals 0. It's starting. And I think just to make my life a bit easier, I'll define another local variable here called and no stop equals to not ESD, or because I think I'll use this a lot, cooling or power off. I think I'll use this a lot. That means I can actually replace this if no stop, and it's a lot easier to read, right? Else if no stop and temp level is greater or equal to 1, then it's running. But that will ignore the meltdown, and then I also want an and temp level is less or equal to 3. Let's check. If it's above this one is level 1, above this one is level 2, above this one is level 3. So that would mean it could actually go all the way up. No, I don't want level 3, I want level 2. Okay? Then it's running. If it's between those two and it does not have any stop applied. Great. And cooling. Let's just say if cooling, which would be stupid, because if you have emergency shutdown, you don't want it to display cooling, or if you have no power, you don't want it to display cooling. Power off, I mean. So if not is emergency shutdown and cooling, and put in here or, because we have variables saying when it should be cooling and should be okay, not emergency or power off. Then we want it to display cooling. Cool, right? I'm so funny. Now we want alarm state. And I wanted to display alarm if it's, first of all, if the temp level is greater or equal to 3, but not only that, I also want to check if there's no there's no stop applied. Let's see, stop applied. If stop is applied, then I don't want any alarm. If stop is not applied, and temp level is above or equals to 3, then it is an alarm. And not ESD, of course, because ESD will be meltdown. I want it to display meltdown as soon as it hits ESD, and then I don't want it because this one will overwrite the meltdown, since the else if is before the meltdown. Okay, depleted. Let's that is if it's the same as above, not stop applied. Wow, almost looks like I pronounced it. Applied. Because if there is, I should actually have a variable called running. I mean Boolean value saying it is running, but not stop applied. That means if it runs and producing, didn't I have a Boolean value? Name this producing it, and stop applied or producing EU. If it's will this work? Because this will only give true if both of those are false. That sounds wrong. Oh, yeah, no, that's true. If stop applied is false, that means if you have running signal, well, if you have, yeah, I think it would be correct. Or producing EU. I believe you just have to test this one. So if you're not producing EU and stop is not applied, you are depleted. Yeah, it works for me. And lastly, but not least, we have to start with not ESD. I didn't use the no stop so much as I thought I would. Not ESD or cooling. This seems wrong. And power off. Because if it has a power off signal, and actually I want this to override the cooling, because power off goes over the cooling, and the cooling states will not be shown if it's powering off, so that's great. Okay, I think we're done. I think we're done. And I think we have to do some troubleshooting. If this works in the first try, this will be amazing. So let's try nuclear, and it says starting. Let's see. You must heat up to there to get into running. Are you cooling off too much? Okay, let's take out 3 of these. Oh, yes. Do need a new thermometer. Let's take out 1 more. This is too slow. Take it 2 more. Okay, so this is starting. I hope it will be starting up to about now. Running, yes! Oh, this is so lovely. This is so lovely. And now it will be running all the way, I hope all the way up there. But let's test it to go into the next temperature level. I believe it's in the next level. Yes, it is in level 2. It is still running. This is great. And let's see what happens when it reaches this top. I really hope it goes into cooling mode, because now we're just testing the normal. It goes into cooling mode. Oh, this is awesome. And a lot of weird stuff happened. Okay, so now it's just working between those 2 temperatures. It's running. It will reach very shortly. It will reach like level 3. Let's see, level 3 is cooling, producing EU. Stop applied is true, and oh yeah, that's right. It will stop producing EU. This will be some lag between the cable, and this is working and showing running and cooling. That's awesome. Oh, let's try the depleted. Let's say I now I have to take it out while it's on, so let's turn off this so it will work for quite some time. And if we take this one out, I'm hoping it will say depleted. It is running, thank you very much. And it's cooling off. Will it say... Oh, it says starting. Okay, let's figure out what went wrong with the depleted status. Edit, nuclear. Let's see, check state. Why did you say running? Maybe we have to say and producing EU like this. Now it says starting. Let's give you some nucleus and let's get you up in to a working range and give you more cooling like this. You're soon up into normal working temperature. I didn't think about that, because if this now depletes, it will cool off and the message will go away. I don't want that. Okay, so now it's running. Let's take out the uranium. Did I get it? Yes, I did get it. I have to be fast. And it says depleted. I want this depleted to stay there until it's producing EU again. Because what will happen now is that when it gets below the 500 degrees, it will say starting again. Yeah, I was afraid of that. Unwanted function. Okay, let's try solve that. There's a lot of small things we have to work out. What we can do, let's make a new variable here called depleted equals false. Okay, and when it gets the status depleted, we will also say depleted equals true. So we use this signal to hinder this to go to starting again, and not depleted like this. So what do I need to turn it off again? No worries. And depleted equals... No, I can't just put it false in the beginning. No. I just have to make an... yeah, I'll just... If producing EU, then depleted... This will just reset it. Fleece? That's the worst false I ever seen. Okay, so why did I make this a local depleted? No, because that will be deleted, I think, every time the function is not running. Okay, so if it's producing EU, it will actually say it's not depleted, and it will reset it. Testing time. It's starting. Let's give it some nucleus. Don't worry, be happy, and let's help the temperature get up a bit. Come on, come on. And let's put it back. Like this. Temperature is rising. And it says it's running. And it's getting night. Let's take your precious uranium. What do you say? Screw that. I spent so much time trying this. Okay, okay. It's heating up. Let's wait a few extra seconds. Okay, let's now take this. It will cool off a bit slower. It will say depleted. Why didn't it go to depleted earlier? Okay, it will still say depleted. Remember, this only updates every 2 seconds with the code we have. Let's give it some more cooling, and it still says depleted. I don't know why it didn't work the first time. Maybe it is just one case it does not handle, like it did not reach this one before I actually went into depleted mode. And I hope that now once I put in this one again, because that is the whole point of that status, is I should know on my board over there that it is depleting. It's starting again. Great. Now we don't have so many other functions to test. Let's see, what else do we have? What else do we have? Yeah, test the temperature range. Yeah, the MFSUs. Let's have it power up a bit. And this one needs to be low, as we learned, to even manage to stop the reactor. Okay, so now it's up to temperature level 2, is it? Yes, and it's running. Let's now say that this one turns full. Emits if it's empty, and it'll turn off. And it says power off. This one will have the same issue, I believe, when it goes all the way down. No, it will not, because the power off will actually stay on as long as it tries to turn it off. So even if we cool it down quite a lot, let's put in all the vents, and we see its temperature level 0, and it's still power off. That's nice. Now we start using energy, and this one will not light up anymore. It will still be power off because it is waiting for the bank to deplete some more. So let's make this output energy if partially filled, and it will start up again. Oh, nice. Okay, no, I have so much cooling at the moment, so it will not heat up. Now I want to test alarm, and that is if it's above this section, and it's could not turn off, I guess. Yeah, if it's above this temperature level and cannot turn off. So if I do this, I'll just force this signal to be on. I hope this will work. Okay, let's take out some cooling vents. Do you heat up? Yes, and we want to reduce this, so we will reach our goal faster. Same with you. Let's make it 2000. Okay, so now it's running. It will try cool off, but it will go into alarm state, I'm hoping. It's in cooling mode. Why didn't you get into alarm state? I was afraid of that. I'll just let it work. No, it will not work, because I'm terminating the program. Okay, alarm state did not work. What happened? What did not happen? Okay. Yeah, this was the one I was afraid. No, this was the one. No. Never mind. Because if there is no SD and Temperature level is greater or equals to 3, which means it has to pass 1, 2, 3 above this one. Why no alarm? It did specifically say it was still cooling. Maybe this was true. Yeah, I guess that is what happened. This sentence was true when it actually was an alarm. So let's make this only say cooling if stop is applied. Because applied. If it did manage to apply stop, it is actually cooling. Makes sense. Starting. Okay, and we will override the program. So now it's running because it's above level 1, and it will still be running in level 2, and once it hits level 3 it will be alarm. Yes. And if you turn off this, it will cool down again, and it will actually go to cooling instantly. Nice. And if we do get this to 2.5K, I'm hoping it will go to meltdown and completely shut down this thing. And if that works, my guys, we are done with the main program. Okay, so it will go first into the alarm states. It's nice, and it will be in alarm state in level 3 and 4, and it goes to meltdown at level 5. That's great. So that means if you turn this off, it will be in stopping mode. It's great, and we'll cool off. Let's help with the cooling. Cool. We'll cool off. It's still stopping, and it's great to see it's working so far. And this program is so much simpler than the program I made in my first video. Trust me, this is easy compared to what I did. I did a lot of plundering. It did not update the last value before going in here. Reactor have stopped because of overheat. Please check the cooling. Press any key to start reactors. Press any key, and it's starting. Okay. What to do? Can I fix the error? What was the error again? Yeah, it did not update. I had plenty of cooling. I should be able to terminate the program. Edit nuclear. It did not update the screen when it run the ESD. Let's see. Let's just do draw screen. No kitty. Bad kitty. Okay, draw screen. My kitty doesn't know English. I don't know why I was talking English to her. And I think that will be the solution. Why am I typing exit nuclear? It's starting. Let's send it into oblivious meltdown again. I'm not doing this. It's just to get the temperature up a bit faster. Alright, I have to override the control system. And I think I should pull out one of these now. And it will be an alarm state, goes to level 5, it will be meltdown. Nice. And then you'll allow to stop it, and you have to stop it completely. And I'll help you cool it off. I wonder, are you going to deplete it now? I don't think so, because Yeah, that's right. Because they have to apply the start signal for it to say it's depleting. Now I hope it will say stopped when it reaches level 0. Well, it updates and shows. It does not update this one. Because it's updating. Because the state is updating after this code. Edit new. Let's fix the last bit there and we are done. What I meant is that down here I have read the nuclear read the states, and yeah, let's just do it in the beginning as well here. Nuclear states equals check states. I believe that will solve the problem. Nuclear, starting, pull out the cooling, go to meltdown. Yes, and override, so it will overheat. It'll be heating, running, and now is alarm, and now we should pull out the radium, and now we should pull out the last uranium, and it should say meltdown as it depleted. Ah, right, because we have forced this signal stopping. Okay, let's apply some cooling. Cooling, and it's night. Let's be day, because I'm God. Level 3. So now I hope it will actually say it's stopped, and level 1, and then say level 0 stopped, and great. Guys, we have a nuclear control system which updates all info on the screen. Isn't this great? It took some time, and I did tell you this would be a long, boring episode of a lot of code. It went actually pretty smoothly this time as well. There was not too many bugs to work out. There is probably a few more bugs, and I would say this program is working a lot better than the last program I made. That might be because I have a lot more experience using Computercraft. As of now, I'm starting to make own APIs. I'm using argument passing. If you want to know what those are, you just give me a shout. I might teach you that. And in the end, I would say, if you want to say hello to me, I'm playing on a survival multiplayer server on Computercraft. You can find the information down in the description. So if you want to come and say hi, or if you just want to play on the same server as me, you are very welcome. It's a very nice staff. It's nice people to play with. They really take griefers by the roots. They are very quickly to repair the server. I actually feel kind of safe there. They have some donation ranks where you can get some cool perks like flying and some heavy voltage solar arrays, like a nice start boost also. So if you have some questions about the program, or if you want to have an idea, can you make this? I mean, I want to have an factory doing this and this and this, controlled by Computercraft. Is it possible? How can I actually solve it? And we can actually take a small talk together. So this was it for part 3. Well, part 2 of part 3. As always, I hope you enjoyed. I hope you liked what you saw. I hope you maybe learned something. I do not learn you basic Lua programming, but I'm showing you how you can program a bit more complicated stuff than just a turtle making a tunnel. So for the next part, we will start getting information up on the monitor, and then it will be complete. So if you like this, please press like. Always a cheer up for me to make more videos, and see you next time. We will make use of RedNet and send the message over to another computer, which will log it and actually output alarm if there's something wrong going on, and you will get a notice immediately, and you can look it up on the board. So let's get into it. First we have to make a code to activate the RedNet modem on top. So edit nuclear, and the best place to do it is in the beginning of the body code. Let's see, it should be around here, and it's so easy. It's rednet.ok.